Hi everyone, in this video what we're going to do is figure out what the limit is as x approaches 0 of x plus 1 divided by 1 plus sine of x all raised to 1 over x squared. Let's begin by rewriting our limit in the following form. The limit is x approaches 0 of e raised to the natural logarithm of x plus 1 divided by 1 plus sine of x all raised to 1 over x squared. Notice here we haven't done anything because e raised to the natural logarithm of x is just equal to x. Now what we can go ahead and do here is bring the power down front using the power rule for the natural logarithm, and we can also move the limit inside the exponential function as the exponential function is continuous. So let's do that. So we're going to have e raised to the limit as x approaches 0 of the natural logarithm of x plus 1 divided by 1 plus sine of x divided by x squared. Now notice what would happen if we were to let x go to 0. In the numerator we would have the natural logarithm of the limit as x goes to 0 of x plus 1 divided by 1 plus sine of x. This would just go to 1 and this would also just go to 1, so we would be left with the natural logarithm of 1, which is equal to 0, and of course in the denominator we would just have the limit as x goes to 0 of x squared, which is also equal to 0. So our limit is of indeterminate form, 0 over 0, and in order to solve it we can use something called L'Hopital's rule. L'Hopital's rule basically says that if you have a limit as x approaches some value c of a function f of x divided by another function g of x, then this limit is equal to the limit as x approaches c of the derivative of f of x divided by the derivative of g of x, given that f and g are both differentiable at c, and that the limit is of indeterminate form 0 over 0, or plus or minus infinity over plus or minus infinity. That criteria is satisfied for our limit right here, so let's go ahead and apply L'Hopital's rule. We're going to have e raised to the limit as x approaches 0. Now, in order to take the derivative of this part here, we're going to have to use the chain rule. So the derivative of the natural logarithm is just 1 over its argument. And now we need to take the derivative of the inside part using the quotient rule. So we have 1 plus sine of x multiplied by 1 minus x plus 1 multiplied by cosine of x, all divided by 1 plus sine of x all squared. And this is divided by 2x. So let's clean this up a little bit. We have e raised to the limit as x approaches 0 of 1 plus sine of x divided by x plus 1 multiplied by 1 plus sine of x minus x times cosine of x minus cosine of x, all divided by 1 plus sine of x all squared, divided by 2x. Now notice we have a factor of 1 plus sine of x here and 1 plus sine of x all squared here, so we can cancel this, and simplifying further leaves us with e raised to the limit as x approaches 0 of 1 plus sine of x minus x times cosine of x minus cosine of x divided by 2x multiplied by x plus 1 multiplied by 1 plus sine of x. So all we've done is basically multiply the numerator and the denominator by x plus 1 times 1 plus sine of x in order to cancel this product here. Now notice that this limit is actually of indeterminate form, 0 over 0 again. Sine of 0 is just 0. X times cosine of x is just 0 because we would have 0 here. And minus cosine of 0 is just minus 1. And we would have 1 minus 1, so we'd have 0 in the numerator. And we have a factor of 2x here, so that would just be equal to 0. And it's multiplied by everything in the denominator. And anything multiplied by 0 is also 0. So let's go ahead and apply L'Hopital's rule for a second time in order to solve this problem. We're going to have e raised to the limit as x approaches 0 of cosine of x minus cosine of x plus x times sine of x plus sine of x divided by, now in order to take this derivative we're going to have to use the triple product rule, so we'll take the derivative of this part, keep these two the same, take the derivative of this part, keep these two the same, and then take the derivative of the last part and keep these two the same. So we're going to have 2 multiplied by x plus 1 multiplied by 1 plus sine of x plus 2x multiplied by 1 plus sine of x plus 2x times x plus 1 times cosine of x. Now these two just sum to 0, and if we were to let x go to 0, in the numerator we would just have 0, and in the denominator anything that's been multiplied by 2x would just go to 0, so this would just be 0, and this would just be 0, and this right here would be equal to 2. But it doesn't really matter what we have in the denominator as long as it's not 0, because we have 0 in the numerator, we just have e raised to 0, and this is just equal to 1, and this is our final answer to this problem. Thank you very much for watching. I hope you found this content useful. If you did, could you please make sure to like and subscribe, as it really helps the channel out. If you have any questions, leave them in the comment section below. I hope you have a great day.